So ventilation, the process of breathing, takes a round trip through the nasal cavity, the oral cavity, makes its way through the pharynx, the larynx, the bronchi, and down to the alveoli, the air sacs. They're surrounded by that simple squamous epithelium, which allows oxygen and carbon dioxide to be exchanged with the capillaries, help from those. And with inhalation, we see a contraction of the diaphragm, contraction of the external intercostal muscles. The ribs go up. We see a increase in the intrapulmonary area and a decrease of pressure. And according to that pressure gradient, the air is going to move into the lungs. And at one point, the pressure is around -1 millimeters of mercury compared to atmospheric pressure. And so according to the pressure gradient, the air moves in, and the process is really complete when atmospheric pressure and the pressure in the lungs match. When it comes to exhalation, we see really a relaxing of the diaphragm, relaxing of the external intercostal muscles. There's a recoiling of the lungs, natural recoiling, and we see air move out. We see the volume go down, decrease. We see an increase in pressure, and this causes air to move out of the lungs. And so that's really basically ventilation. It's really an example of Boyle's law, which states that when there is a decrease in volume, there is an increase in pressure in an enclosed area, and when there's an increase in the volume, there's a decrease in the pressure. And so we see that here with the lungs. Really, it's with ventilation example where volume affects pressure, which affects airflow. And so also I just wanted to point out that there are examples where we engage in forced inhalation and exhalation. Maybe we're exercising, we're running, lifting weights, and when those, we see these other muscles get involved. Maybe the ribs need to move up quicker, higher. So when it comes to forced inhalation, we may see the scalenes get involved, the sternocleidomastoid muscles may get involved, as well as the serratus anteriors, the pectoralis minor. When it comes to forced exhalation, we may see the internal intercostals contract, as well as the abdominal muscles, the transverse thoracis. And so while they may contract, we are seeing a relaxing, though, of the diaphragm and the external intercostal muscles. Also, just a quick shout out to other important areas in the body with regard to ventilation, namely the respiratory areas of the pons and medulla. Our breathing rhythm, the book points out, stems from the ventral respiratory group, the VRG. Also, the dorsal respiratory group, the book points out, pulls some strings in certain ways, and with regard to rhythm modification. And moreover, the brain keeps up with carbon dioxide levels, as well as levels of hydrogen ions, levels that provide a big impetus to how the brain engages in ventilation.